In the previous lesson, we have been talking about generalization, overfitting, terms that for machine learning systems are a bit intuitive. But in this lesson, we're going to formalize a bit this concept. In fact, in this lesson, we're going to have a short introduction about the theory of statistical learning. What we will see in this lesson, we will introduce the theory of statistical learning. We will see what generalization means for machine learning systems, and we will talk about validation, which is the way to achieve generalization. Let's go in bit in detail. What is statistical learning? The goal of statistical learning is to build a function, also known as a model, that establishes a relation that estimates an output, also known as dependent variable, based on one or more input, also known as independent variables. The parameters of this function are discovered, or well said, are learned directly from the data. Successful learning strategies are supervised learning, unsupervised learning, and reinforcement learning. We will talk about this strategy in next lesson. What does it mean, generalization? In order to build an effective model, training data needs to be used in a way that would make the model generalizable for unseen data. What does it mean, generalizable? In general, in research, generalizable refers to the ability of research finding to be applied to a wider population or a context beyond the specific study or settings. In other words, if the results of a study are generalizable, they can be considered representative of a large population beyond the participant of the study. What does it mean for a machine learning model? It means exactly the same. The output of a generalizable model should be consistent with the training data, even if the inputs during the inference time are not exactly the same of the data used for the training. Which are the main problems that we can find into the generalization process? We can find mainly two inconsistencies. Which are the problems that we can find during the generalization process? If the model is too simple to fit the data considered, we are in a situation called underfitting, which we can see here in the left of this picture. We can understand that this model, the straight line, will not be able to actually represent the data and to predict new data when they will come in the inference phase. On the other hand, we can find that the model is too complex for the data provided. And we see this on the right side of this picture, where the model is going up and down, trying to learn actually by memory the data that are present in the data set. And this situation will actually produce output that are worse with respect to the generalizable model, just because the model is not able to have a general concept of the distribution of the data. In fact, the just right function to represent this data may be the one here in the center, which bring together the main characteristics of this dataset. But how can we achieve generalization? How can we control that the model is not in underfitting or overfitting? We use validation. In order to avoid underfitting and overfitting, the model needs to be tested on a set of data that is similar to the training data, but has not been used for the training. This set, known as test set, is taken out from the full dataset available. There exist several strategies for testing our machine learning model. One of them is known as split 70-30, where 70% of the data is used for training and 30% is used for testing. There are other slightly more complicated strategies for testing machine learning model known as cross-validation or leave one out. So, to recap what we learned in this lesson, the statistical learning theory is a framework that lays the theoretical foundation about how to learn function, or better, models that associate an output in relation to input. Models should be generalizable, which means they should be able to work well on examples that have not been presented during the training phase. An unseen test set is needed to validate the model in order to assess its performance on unseen previously data.